Washington, D.C. is gray, cold, and suffocatingly bureaucratic. It is early 1986, and the city feels like a tomb. Richard Feynman hates it here. He is a creature of sunlight, bongos, and blackboard equations, not committee rooms and redacted documents. He sits in a stiff chair, surrounded by piles of paper that smell of toner and evasion. His body is failing him. A rare cancer is slowly eating away at his reserves, but his mind is vibrating with a familiar, restless frequency. He is hunting. The Rogers Commission is supposed to find out why the Space Shuttle Challenger disintegrated 73 seconds after liftoff, killing 7 people. But to Feynman, it feels like they are being paid to bury the truth, not dig it up. NASA managers speak in acronyms. They present charts that look like spider webs. They talk about safety margins and acceptable risk until the words lose all meaning. Feynman is an outsider here, a wild card thrown into a deck of stiff suits. He prowls the halls, pestering engineers, ignoring chains of command, asking the dumb questions that no one else dares to ask. But he is hitting a wall. The data is too vast, the obfuscation too thick. He needs a compass. The breakthrough does not come in a secure briefing room. It comes in a garage. General Donald Kutina, a fellow commissioner who has taken a liking to the eccentric physicist, invites Feynman over for a Sunday afternoon. It is a casual setting, disarming. The smell of gasoline and old oil hangs in the air. They are looking at Kutina's Opel GT. It's a moment of male bonding, seemingly trivial, but the air is thick with unspoken intent. Kutina is a military man. He understands the chain of command, but he also understands duty. He knows things he cannot say on the record. He points to the carburetor. He mentions how it acts up in the cold. It's a strange, specific conversational detour. "I was working on the carburetor this morning," Kutina says, casually, "and I was thinking about the shuttle. What happens to the seals when it gets cold?" The question hangs in the damp garage air like a suspended cord. Feynman stops. His eyes, usually darting with manic energy, lock onto Kutina's face. He sees the signal. This isn't about a car. This is a breadcrumb. Unbeknownst to the public, and even to Feynman at that exact second, the source of this breadcrumb is Sally Ride, the first American woman in space. She is sitting on a terrifying secret. She knows the data. She knows that the solid rocket boosters have a fatal flaw, a vulnerability to low temperatures that NASA management has systematically ignored. But she is an astronaut. She is inside the machine. To blow the whistle publicly is to end her career and burn down the institution she loves. So she passes the flame to Kutina, who passes it to the one man wild enough to start the fire. Feynman's mind races. He thinks about the launch day, the icicles hanging from the gantry, the temperature dipping below freezing. He thinks about rubber. Rubber is pliable, alive, but when it freezes, it dies. It becomes hard, it loses its memory. If the O-rings, the giant rubber bands sealing the volatile fuel segments, lost their ability to expand, the gas would escape. The flame would act like a blowtorch. The shuttle didn't just fail, it was murdered by the weather and the arrogance of ignoring it. He leaves the garage, his heart hammering against his ribs. He doesn't just have a theory anymore, he has the smoking gun. But a theory is nothing in Washington. He needs proof, and he needs it before the political machine cements its narrative of unavoidable accident. The truth is cold, and he is about to make everyone feel it. The night before the televised hearing, Feynman is a man possessed. He is pacing his hotel room, the carpet worn thin under his shoes. He knows how this game is played. Tomorrow, NASA officials will sit in rows, armed with glossy charts and thick binders. They will drown the cameras in thermal gradients and blow by anomalies. They will make the death of 7 astronauts sound like a complex, unfortunate math error. If Feynman tries to argue with them using physics equations on a blackboard, the public will tune out. The commission will nod politely and bury his dissent in an appendix of a 1,000-page report that no one will ever read. He needs a weapon. He needs something visceral, something that a grandmother in Kansas and a school kid in the Bronx can understand instantly. He walks out into the city. He finds a hardware store.
It's a mundane place, smelling of sawdust and cheap metal. He wanders the aisles, a Nobel Prize winner looking for a C-clamp. He tests the pliers. He buys a small vice grip. The clerk likely has no idea that the disheveled man buying $2 worth of tools is about to dismantle a billion-dollar lie. Back in his room, he practices. It has to be perfect. If he fumbles, he looks like a confused old professor. If the rubber doesn't behave exactly as he predicts, he will be humiliated and the truth will be lost. He sleeps fitfully, the phantom image of the shuttle explosion replaying behind his eyelids. The morning of the hearing is bright and brutal. The television lights in the hearing room are hot, baking the air. The room is packed. Senators, generals, reporters, and the families of the fallen astronauts are all watching. The NASA managers are already testifying, their voices smooth and practiced. They are building a fortress of words. They talk about the O-rings, admitting there were concerns, but insisting that the data was inconclusive. They are weaving a narrative of complexity, suggesting that no single factor could be blamed. Feynman sits at the long table, fidgeting. He looks at the glass of ice water in front of him. It's for drinking, a courtesy for the speakers. But to Feynman, it is a laboratory. He checks his pocket. The piece of O-ring material, obtained from a model, is there. He reaches for the C-clamp he hid in his lap. His heart is beating a frantic rhythm, but his hands are steady. This is it. He waits for a lull in the drone of bureaucracy. He quietly picks up the C-clamp. Under the table, out of sight of the cameras, he squeezes the black rubber in the vise. He tightens it until the rubber is crushed flat. Then, with a casualness that belies the screaming tension in his gut, he lifts the clamped rubber and drops it in his glass of ice water. Clink. Nobody notices. The testimony drones on. Feynman watches the glass. Condensation forms on the outside. Inside, the rubber is chilling. The molecules are slowing down, locking into place. The elasticity is being stolen by the ice. He glances at the clock on the wall. He needs a few minutes. If he pulls it out too soon, it might spring back. If he waits too long, the moment will pass. He is performing a high-wire act with a glass of water. He looks around the room. The faces are serious, bored, confused. They have no idea that the most important physics experiment of the decade is happening right in front of them, inside a drinking tumbler. The tension is a physical weight on his chest. He clears his throat. He reaches for the microphone button. It's time. Feynman hits the button. The red light on his microphone glows, a small, angry eye. He interrupts the proceedings. His voice is scratchy, rasping, lacking the polished baritone of the politicians, but it cuts through the room like a serrated knife. He apologizes for the interruption, playing the part of the confused academic, disarming them. "I took this stuff that I got out of your seal," he says, holding up the dripping clamp, "and I put it in ice water." The cameras swivel. The room goes quiet. A few people lean forward, squinting. What is the old man doing? Is he thirsty? Is he senile? Feynman's hands are wet. He holds the C-clamp up to the light. The ice water drips onto the expensive tablecloth. This is the moment. Everything hangs on the physics. If the rubber snaps back to its original round shape, NASA is right, and he is a fool. If it stays crushed, the shuttle program was a death trap. He releases the clamp. The room holds its breath. The rubber does not move. It does not spring. It does not snap. It stays flat, deformed, a crushed, lifeless piece of black junk. It looks like a dead thing. Feynman holds it there, letting the image burn into the retinas of the world. "I believe that has some significance for our problem," he says, his voice flat, devastatingly calm. He explains that at 32 degrees, the temperature on the launch pad, the O-rings ceased to be seals. They became gaps. They became open doors for fire. The silence that follows is louder than the explosion itself. In 3 seconds, with a glass of water and a dollar store clamp, he has destroyed months of cover-ups. The NASA officials stare at the rubber, their faces draining of color. The complexity is gone. The excuses are vaporized. It wasn't a mystery, it was physics. and physics doesn't care about your budget, your schedule, or your political reputation. The hearing eventually continues, but the energy has shifted. The lie is dead on the table. Feynman's demonstration becomes the defining image of the disaster. Later, in his personal appendix to the report, which he fought tooth and nail to include, he writes the words that will serve as his epitaph and a warning to every engineer who follows. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. He was tired. He was dying. But in that moment, he was the sharpest mind on the planet. He didn't just solve a puzzle, he saved the future of space spites from its own vanity. He reminded us that the universe has rules, and those rules are absolute. You can spin the press, you can bully the engineers, but you cannot negotiate with the melting point of rubber. Today, that glass of ice water isn't just a piece of history, it is a challenge. In an era of deep fakes, spun narratives, and alternative facts, Feynman's wet, crushed O-ring sits on the desk of our collective conscience. It demands that we look at the raw data, no matter how uncomfortable it makes us. It asks if we are brave enough to clamp the truth in ice and see if it holds its shape. Because eventually, the ice always melts, and the truth, like that shuttle, will either fly or it will burn.